Hey everyone, in this video I'll show you how to micro-benchmark your CPU and GPU with MicroBenchmark GUI app from Clam Chowder. I'll add the links in the description. So if you are wondering what this does and why do we need it, so basically you can just test the memory bandwidth from CPU, GPU, the cache and everything, the entire SoC, and even to gauge what is the maximum bandwidth, what is the latency once you cross the cache sizes, and how it scales across multiple threads. So these GPU operations are carried across through OpenCL, not CUDA. So one thing I want to mention is this is similar to ADA's CPU and memory benchmark, but you can't compare it side by side to gauge the performance because the calculations of a kernel is completely different, and even the handwritten instructions might be different. So let's get started on how to run it and what each of the things are. The first and foremost, you'll see that this is a very minimalistic GUI app written in C#, I guess. Yes. So the much focus is gone into the actual logic of how everything is calculated. You'll see that a few of the things will change. So by default, if you have AVX 512, it will default to 512. If you don't have it, it will default to AVX or anything that is particularly suitable for your CPU or SoC. So MMX is very old one. I think if you are using Pentium, I do use Pentium. It's a very old Linux machine. So it has only SSE4 and MMX. Then again, I'll just start with the 16 threads. You'll see some notification saying that from NVIDIA broadcast. So once I'll run this, so we'll just keep it at default. You can check or select whichever access mode you require. You can actually mix it with read, write, modify, or just the instruction fetch. Depends on your use case on how do you want to benchmark your CPU, GPU, and memory and IO system. So let me start. Let's see, let me just run it, and you will see that the data set, data size depends until your memory runs out. So I have 32 gigs of memory, so that's why we use a very high memory count. So the reason why lower data set is ignored, because when you have 16 threads, it won't calculate for these lower data sizes and starts from, so think of it as assigning 1 KB for every 16 threads, so 1 into 16, so it starts from 16. So you can just tweak your thread counts to see how good your IPC is and things like that. So you can change the colors, and you can even, I'll just cancel it so that you can actually get a comparison of how the plot works. So I'll just reduce the counts to 8. Now you'll see a secondary plot with a different color, something like this. So you'll get a comparison plot, how it scales well across multiple threads or any of these access mode with AVX512, AVX5, AVX2 or SSE. So I think that is pretty much it for the CPU memory bandwidth. I think you can even clear the results. Even you can export it as a CSV or in a JS format. I'll stop this benchmark. So depending on your system configuration, it does take a long time. Now this is similar to your ADAS cache and memory benchmark. So usually you see better benchmarks or memory bandwidth when you use large pages. So I'll do a test run with both the paging modes, the default, the 4 KB and large pages as well. I'll just run few of the data sets just to give a comparison. I'll just open Excel sheet as well so that you can see how it is exported. So in simple terms, lower the latency, better the bandwidth. So once you go out of the cache sizes, so since I have a 8840 hog point, you'll see that after 16 MB of L3 cache, you'll see very high latency as the memory access gets a huge penalty. This is our getting very huge latency after 8 MB, which was not the case when I ran it a couple of days ago, even on the same BIOS. 190 is very high. But then again, I'll just cancel it so that I can run a different one with a large page size. So in the meantime, I'll just export it to a CSV format. I'll just use Control A, just select this test run and then give export. Otherwise it'll be stuck in the same old test results. So you have to do a clean export every time. Right click on file. Okay. Let me see if I can drag and drop the files. Okay, now it is rendered properly. I'll just so you can even insert a chart if you want to do a stacked bar. You can also do that. So similarly, you can run it for NVIDIA CUDA. I mean, this is an OpenCL 3 version. Just let me just check. I think it is OpenCL 3. So I'm using GPU gaps here to see. So AMD is using 2.1, NVIDIA is 3. Yeah, it was 3. So you can clear the results if you have too many results. So I'll do a quick test run. No. So even you can control the color of the chart which you require. So I just kept it as default. So make sure you warm up your GPU, because on the initial run it will be slightly slower. So just warm up your GPUs, especially when you have NVIDIA Optimus or something. So I'm currently running it as a eGPU. You can see that, yeah, you can hot plug it via the Thunderbolt. So I'm using USB 4 and not the Thunderbolt. So I'll just do a quick test run for AMD Radeon, the iGPU. So if you're seeing why I have only assigned 2 GPs, because Radeon allocates the memory from the RAM and it dedicates the entire 2 GB. So by default it is 4 GB, so you can extend it up to 8 GB if you don't have any external GPU on your laptop or your mini PC. So the reason why I switched to 2 GB was since I have a external eGPU, external GPU with NVIDIA, and I didn't want those additional RAMs, the unused RAM, to be dedicated and simply lying waste. So I just reallocated it back to Windows. So you need to get into BIOS to adjust the changes. So you do have to reboot your machine to whenever you change the memory. That's completed. And so once you're done, you can just submit the results. So you'll see some firewall if you have configured one. So I've already whitelisted it. Once you submit, you'll see a result here. So this scales across your size of the dataset size. maximum bandwidth is 245. So let me switch to NVIDIA. See, $249. I've not completed the test, but yeah, I think I'll get the picture, so you can compare it. We'll test the link speed when you do a copy from CPU to GPU and GPU to CPU. So let's try that out as well. You'll see not that great bandwidth when you are connected to a actual PCI Express. The full width, you'll see a much more higher bandwidth because I'm using by 4 lanes, so instead of 16. So you'll see that very slow link speed as well. So if you are on a desktop, you'll see a better link speed, unless if it is using PCI Gen 3 by 16, because the bandwidth is quite different from PCIe 4 and PCIe 5. So we'll just test the iGPU as well. Do note that everything is for the GPU test, everything is OpenCL and it's not actual CUDA. So I'm not sure if you can run it on Apple M series or Strix Point, because I don't have anything like that with me. Strix Point, I don't think it has yet been released. It has yet released in India, but I'm not sure. The pricing on Strix Point is almost on par with the Blackwell. This one is almost TGX. So I'm not sure. I don't have something like this, and it's not been released yet. So if anyone has it, they can submit the benchmark results. I think the memory bandwidth will be very high for a unified SoC. I'll run the final test for NVIDIA. That is copying from GPU to CPU. Not reflect the actual real world performance, because in the real world, especially on AI and gaming workloads, the NVIDIA 4070 is much more powerful than the iGPU, even with a lower lane count and a 20% deficit while running an eGPU. So on a desktop, I think you will see much better performance than what I'm showing you here. So I think that's it for this video. I hope this was helpful for those who want to do a quick testing of their new shiny PCs or laptops or mini PCs. So you can just keep track of how the performance changes with each Aegisa versions or microcode changes. So this will be one of the best utilities, and it's also free, so you can keep track of the data locally. So if you don't have to submit each results, and you can just keep an offline copy if you're using a very new hardware and you don't want to leak the pre-production scores and keep it private. So I hope this video is helpful, and thanks for watching. Bye.